Lesson 6.7, Solve inequalities by multiplication or division. Multiplication and division properties of inequality for positive numbers. The multiplication property of inequality and the division property of inequality state that an inequality remains true when you multiply or divide each side of an inequality by a positive number. So when we're multiplying or dividing by a positive number with an inequality, our same rules apply as if we had an equal sign. So example A, we have 4x is less than 40. I know I'm taking 4 times x, and I know the opposite of multiplying is dividing, so I'm going to divide both sides by 4. My 4 is reduced down to 1, so x is less than 10. Okay, letter B, we have 6 is greater than or equal to x divided by 7. I know I'm taking x divided by 7. I want to get x by itself. So where's my starting point with my inequality? I know I'm dividing by 7, so I'm going to multiply both sides by 7. That reduces to 1. So 7 times 6 is 42. So 42 is greater than or equal to x. So again, when you are multiplying or dividing by a positive number, it's the same rules as with the equal sign. We bring it over with the opposite of what we have done before. Okay? The next one is multiplication and division properties of inequalities with negative numbers. So whenever we have a negative number, so we're multiplying or dividing by a negative number, the symbol must be reversed for the inequality to remain true. So for example, if we have 7 is greater than 1, if we multiplied both sides by negative 2 and we didn't flip our sign or use the reverse, we would say negative 14 is greater than negative 2. And that's not true. Negative 14 is not greater than negative 2. So we have to reverse our inequality sign, which makes it true. Negative 14 is less than negative 2. So if we go down to letter C, we have k divided by negative 2 is less than 9. So again, I want to figure out what is k. Since I'm dividing by negative 2, I'm going to multiply both sides by negative 2. Those reduce down to 1. So k is now greater than negative 18. Since I multiplied by a negative 2, I brought that negative 2 over. I have to switch my inequality sign or do the reverse of it. And then they asked us to graph it. So I always cut my graph in half, and I start with my negative 18. Okay, when we are graphing our points, first I ask myself, do I need an open or a closed dot? So is this equal to or is it not? Well, it is not equal to, so I have an open dot. And k is greater than negative 18, so I need to move to the right. I need to be bigger than 18. So anything greater than negative 18 to positive infinity will satisfy this inequality. If we turn over to the back, number 3, at a baseball game, you can get a single hot dog for $2. You have $10 to spend. Write and solve an inequality to find the number of hot dogs you can buy and interpret the solution. Okay, so again, I pick out what do I know. I know that it's $2 for a hot dog. I have $10 to spend. I need to write and solve an inequality for the number of hot dogs that I can buy. And then I need to interpret the solution. So I know it's $2 per hot dog. I don't know how many hot dogs I'm buying, but I can spend $10. So now I have to think, what inequality sign am I going to use? Well, I can spend $10, so I know it could be equal to, but I can't go over that $10. So $2 times however many hot dogs has to be less than or equal to our $10. Okay, now that I have my inequality set up, I want to know how many hot dogs can I buy. So since I'm multiplying by 2, I'm going to divide both sides by 2. So h is less than or equal to 5. So that means I can buy 5 hot dogs. I can buy up to 5 hot dogs, but I can't buy any more than 5. So again, when we are multiplying and dividing by a negative number, you have to make sure that you flip your inequality sign. Else our same rules apply as when we would multiply or divide with an equal sign.